Descriptive statistics, page 9 and 10. First we'll finish up this last problem from page 8. A data set has the following known measures of center and spread, median, mode, range, etc. Determine the new value of each of these measures if every member of the data set is increased by 2. Okay, so let's say that you have a distribution and the median is 9 and the range is 13 and the IQR is whatever. Okay, if you increase every single value by 2, that means like all these values are going to be moved 2 to the left, including the median. Okay, so it would be 9 would become 11, the mode would become 9, the range would become, well, actually the range is a difference between two values. So, like, remember that the range is like from the minimum to the maximum. So even if you move it 2 to the right, it's still going to be 13. So that'll still be 13. IQR, same thing. The IQR is the difference between the Q1 and the Q3. If you move both the Q1 and the Q3 2 to the right, it doesn't matter, right? It's still going to be 6. Okay. What if you double all the numbers? What happens then? Okay, so if you double the numbers, then the median, instead of being 9, is going to, well, all the numbers below it, let's say there's 10 numbers below it. The 10 numbers below it will double, but they'll still be below it. So that means the median is still going to be the median, but the median is now doubled, so it's going to be 18. The mode is the highest occurring number, and it was 7, and after it's doubled, it's going to be 14. It's still going to be the most frequently occurring number, so that would be now 14. The range. So now the range, it's going to be twice as wide, because now the maximum is going to be 2 times the maximum. The minimum is going to be 2 times the minimum. The maximum minus the minimum times 2 is twice the range, so it's going to be 26. IQR, same thing. If you double each of the numbers, the IQR is going to be twice as wide. Okay. All right, now 20D, box plots. Okay, so when you make a box plot, you're using 5 statistical numbers, which are minimum, Q1, median, upper quartile Q3, and maximum. And where is each one? So the minimum is going to be the leftmost number, which is marked with this little dot here. Sometimes in some books they'll use a line. And then the maximum, of course, is the highest possible one. The median, of course, is the middle one. And then lower quartile is the left side of the box, and upper quartile is going to be the right side of the box. You can see that the box plot divides the distribution range in 4 sections. What percentage of data are in each section? Okay, remember that each one of these characteristics is separated from the other by 25% or a quarter of the distribution. So there's 25% of the data in between each of these characteristic statistics. Using the test on page 523, give the upper and lower boundaries for outliers if you have the following distribution. On page 523, they give us a rule of thumb that allows us to maybe decide whether a piece of data is too far away from the central part of the data to be legitimate data. And that rule is that the upper boundary for outliers is Q3 plus 1.5 times IQR, and the lower boundary for outliers is Q1 minus 1.5 times IQR. So let's calculate what the upper and lower boundaries are for outliers, given that Q1 is 7 and Q3 is 10. This is just one specific example. Maybe it'll help us figure out how to use this rule. So in this case, the IQR is going to be 10 minus 7, which is 3. And so then the upper boundary for outliers would be, upper boundary is going to be Q3, which is 10, and we're going to add 1.5 times 3, which is going to be 4.5. So the limit's going to be 14.5. The lower boundary is going to be the Q1, which is 7. And then we're going to subtract 1.5 times 3. It's going to be 7 minus 4.5, which is going to be 2.5. Okay, so anything lower than 2.5, we're going to reject. Anything above 14.5, we're going to reject as outliers. Write the symbol used to mark outliers. The book uses an asterisk to mark outliers, okay, on the box plot. Okay, so just to summarize, a box plot has a box over the IQR region, which is the middle 50%. Right at the median of the middle person, there is another additional vertical line. And then on the sides, it's got just straight lines to cover the bottom 25% of the people and the top 25% of people. If you think about the population being distributed along the box plot, 25% of the population is in each one of these lines, and 25% of the people are in the left box, and 25% of the people in the right box. So if you think about where is the middle person in the population, he's always going to be right at the middle line of the box, which is the median. Okay, let's go do a problem. Problem 1. So this box plot is showing how many points are scored by a basketball team. We can see here that the median is going to be right there. It's about maybe 36, so the median is 36. Q3 is about 53 maybe. The maximum looks like it's about 78. You're going to have to eyeball some of these. The Q1 is about 27 maybe. And the minimum is about 12. Okay, so let's see what they're going to ask us. Well, first they're going to ask us the median. We just said it was 36. Upper quartile we said was 53. Maximum values we said was 78. Minimum value we said was 12. And the lower quartile we said was 27. They might be off by 1. Calculate the range in the interquartile range. The range is the maximum minus the minimum, so it would be 78 minus 12, which is equal to 66. The IQR is the Q3 minus Q1, the upper quartile minus the lower quartile, which is going to be about 26. Okay? Alright. Page 10. For the following data sets, construct a 5-number summary, draw a box plot, find the range, and find the interquartile range. So the 5-number summary would be those key 5 numbers we found to make a box plot, which are minimum, median, maximum, Q1, and Q3. So once we do that, once we find those, the box plot is easy to draw, the range is easy to calculate, and the IQR is also easy to calculate. So what I've done is I've put all these numbers into list 1, I've put all these numbers in list 2, and I'm going to use the calculator to find the 5 numbers, the 5-number summary. So I put list 1 first into one of our stats, and I'm going to go out and look at the key 5 numbers, which are here, 3, 5, 6, 8, 10. So those are the key 5 numbers for the first distribution, 3, 5, 6, 8, 10. And the other one would be stat calc, one of our stats. And now we're going to put list 2, calculate, and we scroll down. It's going to be 04789. 04789. So when we do our box plot, all we need to do is mark these numbers on the graph. So, for example, let's see, this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And for the bottom one, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And each one of these is going to be one of the critical points for the box plot. Remember, the box plot has a box in the middle section, and the median is marked with a vertical line inside the box. And then the sides are horizontal lines like that. So for this one, the median is 7. So the box looks like that, and then the lines on the side look like that. You put a dot on the maximum and minimum. Okay, so that's how you draw a box plot from the 5-number summary. And then find the range of each. So the range would just be the maximum minus the minimum. So for the first one, the range would be 10 minus 3, which is 7. For the bottom one, it would be 9 less 0, which is 9. And then find the IQR for each. So the IQR would just be the each side of the box, the difference of that. So it would be 8 minus 5 is 3. And then for the bottom one, it would be 8 minus 4 is 4. Okay, number 5. Enid examines a new variety of bean and counts the number of beans in 33 pods. Her results were, and gives us a whole bunch of numbers here. Not in order, unfortunately. Find the median, lower quartile, upper quartile of the data set, find the IQR, and draw a box plot of the data set. So, again, I think the easiest way is to put it in the calculator, which I'll do offline, and then I'll come back and show you what the results are. I just entered all these numbers into list 1, and then I'm going to do stat calc 1 var stats list 1, and then calculate. And then I'm going to grab the 5-number summary, which is 2, 5, 6, 8, 13. 2, 5, 6, 8, 13. So this is the median, this is the minimum, this is the maximum, and this is Q1 and Q3. Okay, so it asks me for the median, which is 6, the lower quartile, which is 5, the upper quartile, which is 8. Then it asks me the interquartile range, which is 8 minus 6 is 2. And then, really, 8 minus 6 is 2. Oh, 8 minus 5. 8 minus 5 is 3. And draw a box plot. So, let's see, we're going to have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 9, 10, 11, 12. Yeah. Okay, so the box plot's going to have a median of 6. Q1 and Q3 is 5 and 8. And then it's got the minimum at 2 and the maximum at 13. So that's it. Okay. Last one for this section. Ranji counts the number of bolts in several boxes, tabulates the data as follows. Find the 5-number summary. We'll go ahead and put that in the calculator, and I'll be right back. I just typed in my data. I put the number of bolts. I put it in L2. Frequency, I put in L3. Now I'm going to do a stat calc 1 var stats, and I'm going to put L1 or L2 and L3. L2, L3, and I'm going to do my calculate and go down and get my 5-number summary, which is 33, 35, 36, 37, 40. So it says find the range. So the range would be 40 minus 33, which would be 7. The IQR would be 37 minus 35, which would be 2. Draw a box plot. So we would have, let's see, I'm going to put maybe 33 here, 34, 35, 36, 37, 38, 39, 40. There we got minimum, maximum. We got our box right in the middle, compact box. Okay. Draw a box plot. Okay, and then are there any outliers in the data? So how do we figure out if it's an outlier? Well, it's more than 1.5 times IQR from the nearest quartile. So what is the IQR again? it's 2, so 1.5 times the RQR is going to be 3. So let's see, is there something outside of Q3 plus 3 or Q1 minus 3? Q3, remember, is 37, so that would be 40. Q1 is 35, so this would be 32. So is there something outside of 32? Yes, there is. There's 33. And is there anything outside of 40? No, more than 40. 40 is the maximum. So basically there is one outlier. It's at 33, and maybe you can mark that with an asterisk like they do in the book. And that's it for page 9 and 10.